When people hear the phrase empty space, they imagine nothingness, a vast, silent backdrop where stars and planets happen to float, like dust in an abandoned room. That picture feels natural, almost obvious, and that's exactly why Feynman distrusted it. He had a habit of looking at ideas that felt obvious and asking whether they were actually earned or just convenient stories our minds like to tell. Feynman pointed out that what we call empty space is really just space where we haven't put anything obvious. No air, no planets, no stars. But that doesn't mean nothing is happening there. In fact, from the perspective of modern physics, space is one of the busiest places you can imagine. It just doesn't advertise its activity in ways our senses evolved to notice. The mistake, Feynman argued, comes from confusing nothing we can see with nothing at all. Space looks empty because our eyes are blind to most of what exists. We don't see electric fields, magnetic fields, gravitational curvature, or quantum fluctuations. Yet those things are not optional decorations on reality. They are the structure of reality itself. Once you accept that, the whole idea of emptiness starts to crack. Space is not a passive stage, waiting for actors to walk on. It is an active participant. Fields stretch through it, interact within it, and define what can happen. Even light itself does not travel through nothing. It propagates through space that already has properties, rules, and constraints. This is where the psychological discomfort begins. We like to think of reality as made of solid things separated by gaps of nothing. That picture feels safe. It gives us boundaries. But Feynman showed that nature doesn't respect that division. Space is not a void separating objects. It's the medium that makes objects possible in the first place. And here's the unsettling part. Even when you remove everything you can, every particle, every photon, space still refuses to become truly empty. According to quantum mechanics, it can't. There is always a baseline level of activity, a restless jitter built into existence itself. Energy flickers in and out, fields fluctuate, possibilities never fully shut off. Feynman didn't dramatize this to sound mysterious. He emphasized it because it destroys sloppy thinking. If space is active, then the idea of nothing. As a simple absence collapses, nothingness becomes unstable. And that forces a deeper question. If emptiness can't exist, what does that say about existence? Philosophically, this hits harder than people expect. We often imagine the universe as something sitting inside emptiness, as if nothingness came first and matter arrived later. But Feynman's view flips that intuition. The structure of space itself may be more fundamental than the things we think of as occupying it. Matter becomes a pattern, not a substance dropped into a void. This reframing changes how you think about isolation, separation, even individuality. If space is a connected, dynamic fabric, then nothing is ever truly disconnected. Distance becomes a relationship, not a gap. Separation becomes a matter of interaction, not emptiness. Feynman loved this kind of idea because it stripped away comforting illusions, not to make people feel small, but to make them more honest thinkers. He believed that the universe is far more interesting than our simplified stories, and that clinging to those stories limits our ability to learn. Once you see that empty space isn't empty, you can't unsee it. The silence between stars becomes active. The darkness becomes structured, and the universe stops looking like a collection of objects floating in nothing and starts looking like a single, restless system. And the reflection he leaves us with is sharp and unavoidable. If even nothing is something, then perhaps the real danger is not how strange the universe is, but how shallow our thinking becomes when we stop questioning what feels obvious. Once you let go of the idea that space is empty, the next assumption collapses almost immediately, the idea that objects are the fundamental units of reality. This is where Feynman pushed much deeper than most people are comfortable going. He didn't just say space is active. He said that what we call particles are not really things moving through space at all. They are behavior, ores of space itself. That statement sounds abstract until you slow down and really sit with it. We grow up believing the world is made of solid pieces, electrons, protons, atoms, little building blocks bouncing around like microscopic billiard balls. That picture is tidy. It feels intuitive. And according to Feynman, it's deeply misleading. In modern physics, fields come first. Electric fields, magnetic fields, quantum fields, these exist everywhere, even where there are no particles. A particle in this view is not a tiny object with an independent identity. It's a localized excitation, a ripple, a vibration in an underlying field that fills all of space. Think about that psychologically for a moment. If particles are ripples, then matter is not something placed into space. Matter is something space does. The electron is not sitting in space like a pebble in water. It's more like a wave pattern that can only exist because the water is already there. Feynman loved this idea because it stripped away false concreteness. He didn't deny that particles behave like particles when you measure them. He just refused to pretend they were solid little objects when the equations said otherwise. To him, honesty mattered more than comfort. This is why he emphasized fields in his teaching. Fields don't have edges. They don't occupy one point and stop. They exist everywhere, even where nothing seems to be happening. And when conditions are right, they produce events we label as particles. That shift has enormous philosophical consequences. If fields are fundamental, then separateness is not as clean as we imagine. Two particles interacting are not two independent things exchanging something across empty space. They are disturbances interacting within a shared underlying structure. In other words, the universe is less like a warehouse full of objects and more like a single continuous fabric capable of forming patterns. This also explains why quantum behavior feels so unsettling. G. We keep trying to apply object-based thinking to a field-based reality. We ask where a particle is when the better question is what the field is doing. We demand trajectories when the underlying reality only offers probabilities. Feynman wasn't bothered by this confusion. He expected it. He knew our brains evolved to track objects, not fields. A thrown rock matters for survival. A probability amplitude does not. So when physics tells us the world is fundamentally field-like, it's not surprising that our intuition rebels. But rebellion doesn't change the facts. Once you accept fields as primary, many mysteries soften, not because they disappear, but because they're no longer forced into the wrong conceptual box. Particle creation and annihilation stop being magical. They become shifts in energy patterns. Empty space producing particles is no longer absurd. It's inevitable if the fields are always present. And here's where the psychological depth cuts in. If the most basic level O, reality is not made of things, but of relationships and patterns, then stability itself is not guaranteed. Everything we call solid is temporary. Persistence is a behavior, not a property. That can feel disturbing, but Feynman saw it as empowering. It means the universe is not frozen, it's alive with structure. Reality is not a pile of dead matter drifting through emptiness. It's an active system constantly reshaping itself according to simple, unforgiving rules, and the lesson he wanted people to take away wasn't just about physics. It was about thinking. Stop mistaking convenient pictures for truth. Stop assuming that what feels solid must be fundamental. Learn to follow the math, the evidence, the consistency, even when it dissolves your favorite metaphors. Because once you realize that objects are not primary, that space itself is the stage and the actor, one thought becomes unavoidable. If reality is built from patterns, not things, then understanding means learning to see relationships, not clinging to illusions of solidity. Once you accept that space is active and that particles are really just disturbances in fields, the next realization lands with a quiet but unsettling force. Even when everything seems perfectly calm, reality is never at rest. Feynman loved pointing this out because it completely undermines the idea of a stable, dormant universe waiting to be disturbed. According to quantum mechanics, stillness is not allowed. Imagine stripping the universe down as far as you possibly can. No matter, no radiation, no heat. Absolute zero. Classical intuition tells us that this should be the ultimate state of rest, a frozen, silent nothing. But nature refuses to cooperate with that picture. Even in this extreme limit, the equations say something is still happening. Feynman explained that this is not due to experimental sloppiness or hidden particles we failed to remove. It's built into the rules. The uncertainty principle does not allow fields to have zero energy and perfect stability. If a field were truly still, with no fluctuations at all, it would violate the most basic constraints of quantum mechanics. So instead, space itself jitters. Energy briefly appears and disappears. Field values fluctuate. These are not metaphorical statements. They are precise mathematical consequences that have measurable effects. The vacuum is not empty, it is restless. Psychologically, this is where people start to feel uneasy. We are deeply attached to the idea that nothingness is peaceful. We use it as a mental anchor. Silence, darkness, emptiness, these feel like places where motion stops. Feynman showed that at the deepest level that intuition is wrong. Reality does not know how to be quiet. This restlessness is not random chaos either. It follows strict statistical rules. The fluctuations are constrained, balanced, and incredibly subtle, but they are always there, and they matter. They influence atomic behavior, shift energy levels, and even affect the large-scale structure of the universe. What's disturbing is not just that space is active, but that this activity cannot be shut off. There is no switch labeled nothing. Existence has a baseline hum that cannot be silenced. Feynman didn't treat this as mystical. He treated it as a discipline in honesty. If the equations say the vacuum fluctuates, then it fluctuates, whether we like the implication or not. The job of science is not to protect comforting ideas, but to replace them with better ones. And this leads to a deeper philosophical tension. If emptiness itself is unstable, then the boundary between existence and non-existence becomes blurry. Nothing is no longer a clean opposite of something. It becomes a dynamic state with structure, limits, and consequences. That realization quietly undermines many assumptions we make about beginnings and endings. We tend to imagine the universe as emerging from nothing or collapsing back into nothing. But if nothingness is itself active, then those stories may be far too simple. The universe may not have emerged from a void. It may be a transformation of an already restless foundation. Feynman didn't speculate wildly about origins, but he was clear about the lesson. Nature is not obligated to align with human metaphysics. Words like nothing, void, and empty are conveniences, not guarantees of truth. And here's where the psychological depth really bites. If even the vacuum is alive with activity, then stability is not fundamental, it's temporary. Calm is not the default, it's an emergent balance. Everything we experience as steady exists because countless fluctuations cancel just enough to create the illusion of stillness. That idea extends beyond physics. We crave certainty, permanence, and rest. We design our beliefs around them. But the universe, as Feynman revealed, is built on motion restrained by rules, not on stillness interrupted by events. Once you truly absorb that, you stop expecting reality to settle down. You stop being surprised by change. You stop mistaking silence for absence. The vacuum teaches a brutal but liberating lesson. Beneath every calm surface, something is always moving. And the reflection Feynman leaves us with is this: if even nothing refuses to stay still, then perhaps growth begins the moment we stop wait for certainty and start learning to move with the underlying restlessness of reality itself. Once you understand that space is active, that particles are patterns and fields, and that even the vacuum never truly rests, the next realization feels almost inevitable and deeply unsettling. If reality cannot be perfectly still, then true nothingness is not just rare, it's impossible. This is where Feynman's thinking quietly crosses a line most people don't even realize exists. We tend to imagine nothing as the most stable state imaginable. No energy, no motion, no change. It feels like the ultimate baseline, the place where everything could finally stop. But the laws of quantum mechanics forbid that state from ever existing. Perfect emptiness is not allowed. Feynman emphasized this not to be dramatic, but because the math leaves no room for escape. A field with exactly zero energy and zero fluctuation would violate the uncertainty principle. Total stillness would require perfect null, edge, and perfect control at the same time, and nature simply doesn't permit that. The universe enforces a minimum level of activity. So even when you remove everything you know how to remove, something remains. Not matter, not radiation, but a structured tension, a background readiness for change. Space cannot be truly still because the rules themselves demand motion. This idea lands hard because it undermines a deeply held human assumption that non-existence is simpler than existence. Feynman's work suggests the opposite. Nothingness is unstable. It collapses under the rules. Existence, with all its complexity, may actually be the easier state for the universe to maintain. That's a profound psychological reversal. We often think of the universe as something precariously balanced above a void, as if it could all slip back into nothing at any moment. But what if the void itself can't exist? What if reality isn't fighting collapse, but expressing an unavoidable activity built into its foundation? Feynman didn't turn this into metaphysics, but the implication is unavoidable. If absolute nothingness is forbidden, then existence doesn't need a dramatic cause to start. It doesn't require a push from outside. Activity is the default. Stillness would require explanation, not motion. This reframes how we think about beginnings, endings, and meaning. We tend to ask, why is there something rather than nothing? Feynman's physics quietly responds, because nothing is not an option. That answer doesn't solve every philosophical puzzle, but it removes a false premise. It tells us we've been asking the question backward. The real mystery may not be why existence appears, but how stability ever emerges from constant motion. And that brings us back to space itself. Space is not a container waiting to be filled. It's a system governed by constraints that demand activity. Those constraints don't switch off when matter disappears. They are always in force. There's also a persona. The mention to this idea that Feynman would never state outright, but he clearly felt. Humans crave rest, final answers, absolute certainty. We want a place where questions stop. But if the universe itself never reaches that state, maybe our expectation of finality is misplaced. Perhaps uncertainty is not a flaw to be eliminated, but a feature to be understood. Perhaps restlessness is not a problem to solve, but a condition to work with. Feynman's brilliance was not just in uncovering these truths, but in refusing to sugarcoat them. He didn't promise comfort, he promised honesty. And honesty, in this case, tells us that reality cannot shut down, not even in principle. The universe does not drift toward nothingness. It vibrates within rules that demand presence, interaction, and change. And the reflection he leaves us with is sharp and demanding. If even the deepest level of reality cannot be still, then maybe the task is not to search for perfect certainty, but to learn how to think, create, and live within a universe that is fundamentally, unavoidably alive. By the time you reach this point, the science has already done something subtle but profound to your sense of reality. Space is not empty. Particles are not things. Stillness is forbidden, and nothingness itself turns out to be unstable. Now comes the part Feynman understood better than most, the part that doesn't live in equations but in the human mind. Because when you truly accept these ideas, they don't just change physics. They change how you feel about existence. There is a quiet psychological shock that follows the realization that space is alive with activity. We are used to thinking of the universe as mostly empty, with little islands of matter, stars, planets, people, scattered through a vast, indifferent void. That picture gives us a strange comfort. It makes isolation feel natural. It makes separation feel real. But Feynman's view dissolves that comfort. If space itself is dynamic, fluctuating, ruptured, and never truly still, then you are not sitting in a pocket of order surrounded by nothing. You are embedded in an active, restless fabric that never switches off. There is no true background. There is no neutral emptiness. There is only interaction layered on interaction. That realization can feel unsettling, even threatening. We like clear boundaries between here and out there, between me and everything else. A living vacuum blurs those lines. It suggests that separation is not fundamental. It's practical, contextual, temporary. Feynman didn't talk about this in emotional language, but it's hard to miss the implication. If the vacuum is active everywhere, then the universe is not something happening far away while we observe from the sidelines. We are immersed in it, participating whether we like it or not. This is where many people instinctively pull back. They retreat to metaphor. They say, it's just math, or it's only a model. And of course, it is a model. It's a model that works with ruthless precision. The discomfort doesn't come from speculation. It comes from consistency. The living vacuum challenges a deep psychological habit, the belief that stability is the natural state of things. We assume that calm is normal and motion is an interruption. Feynman showed that the opposite is true. Motion is normal. Calm is an achievement. That insight can be disturbing because it strips away the idea of permanent ground. If everything rests on fluctuation, then nothing is absolutely fixed. Not matter, not energy, not even emptiness. Permanence becomes a pattern that holds, not a guarantee that exists. And yet, there is another way to experience this idea, one that Feynman himself embodied. Instead of fear, there can be awe. Instead of anxiety, curiosity. A universe where space itself is alive is not a cold universe. it's an intimate one. It means reality is not built from dead material drifting through nothing, but from active relationships that never fully disengage. Even silence has structure. Even darkness has motion. This changes how you think about insignificance. We often feel small because we imagine ourselves surrounded by emptiness. But if emptiness doesn't exist in the way we thought, then smallness loses its meaning. You are not isolated in a void. You are a localized pattern in a continuous dynamic system. Feynman would never tell you what to feel about that. He resisted turning science into comfort philosophy. But he was clear about one thing. Pretending the universe is simpler than it is does not make it safer. It only makes us less prepared to understand it. The living vacuum asks something of us psychologically. It asks us to let go of the need for absolute stillness, final answers, and permanent ground. It asks us to replace certainty with engagement, and that can be empowering. If reality is dynamic at every level, then change is not an anomaly, it's the rule. Stability is something that emerges when conditions align, not something you're entitled to expect. Feynman's deeper lesson here is not about fear, but about maturity. A mature mind does not demand that the universe provide comfort. It learns how to think clearly inside a reality that is active, uncertain, and alive. And the reflection this leaves you with is simple but demanding. If even empty space is restless, then perhaps the goal is not to seek safety in stillness, but to learn how to stand, think, and act inside motion without losing clarity. By the time Feynman's thinking carries you this far, the disturbance is no longer just scientific, it's existential. Space is not empty. Objects are not fundamental. Stillness is forbidden. Nothingness is unstable. And the vacuum itself is alive with structure and activity. At this point, the uncomfortable question is no longer what is the universe made of, but what does this say about how we think and why we cling so hard to certainty? Feynman's deepest contribution here was not a single equation. It was a way of confronting reality without flinching. He understood that humans are pattern-seeking creatures who desperately want firm ground beneath their beliefs. We want clean edges, past and future, something and nothing, cause and effect, here and there. But the deeper physics goes, the more those edges blur. If space itself fluctuates, then the idea of a fixed background collapses. There is no absolute frame where reality simply is. Everything exists in relation, in interaction, in context. Certainty becomes local, temporary, conditional, and that is deeply unsettling to a mind trained to crave final answers. This is where many people misinterpret Feynman. They assume that uncertainty means ignorance, or that lack of a clean picture means we know less. Feynman's view was the opposite. Uncertainty is not a weakness of knowledge. It is a feature of reality. The rules are precise. What's missing is our ability to compress them into comforting stories. And that distinction matters. Because once you accept it, you stop fighting reality for not behaving the way you wish it would. You stop demanding that truth be intuitive. You begin to value consistency over comfort. This shift has consequences far beyond physics. We often delay action because we want certainty first. We hesitate, overthink, and freeze, waiting for the world to become stable enough to trust. But the universe Feynman described never reaches that state. There is no moment when all fluctuations stop and clarity becomes absolute. And yet, things work. Atoms form. Stars burn. Life evolves. Meaning emerges. Not because uncertainty disappears, but because patterns hold long enough to matter. That is the quiet philosophical punch. Stability is not the absence of motion. It is motion constrained by rules. Meaning is not the elimination of uncertainty. It is what you build while uncertainty remains. Feynman never offered existential reassurance, but his physics carries an imp. Licit challenge. If the universe itself operates without absolute certainty, why should you demand it before thinking clearly or acting decisively? The past is not frozen, it's encoded imperfectly. The future is not written, it's probabilistic. Even the present is a dynamic resolution of countless fluctuations. Reality is not a static object, it's an ongoing negotiation. This doesn't make truth fragile, it makes it resilient. The laws don't break just because outcomes aren't predetermined. They hold precisely because they allow variation within structure. And that's the mental discipline Feynman wanted people to develop. Learn to live with incomplete pictures without lying to yourself. Learn to act without demanding metaphysical guarantees. Learn to think clearly in a universe that does not pause to reassure you. There is something deeply empowering about that stance. You stop outsourcing certainty to authority, tradition, or intuition. You test ideas. You accept provisional understanding. You stay curious instead of defensive. Feynman once said that doubt is not a defect, it's an essential tool. The moment you think you've reached final understanding is the moment you stop learning. A restless universe demands restless thinking. And perhaps that is the most disturbing and liberating thing he uncovered by looking too deeply into space. Reality does not promise comfort, permanence, or final answers. What it offers instead is consistency, structure, and the opportunity to participate intelligently. So the final reflection he leaves us with is not about space or particles or the vacuum. It's about mindset. If the universe can exist without certainty, without stillness, without absolute ground, then so can you. And the challenge is simple but not easy. Stop waiting for reality to become stable enough to trust, and start training your mind to think clearly inside motion, because that is where truth actually lives.